Let's take a look at this example in which we will learn how to find out value of t from the table. Suppose you have a sample of size n is equal to 10 from a normal distribution. Find a value of t such that only 1% of all the values of t will be smaller. Means that we need to find out a value of t such that only 1% of all the values of t will be lying on the left of that value, because the values on the left are smaller than the values on the right. So first we need to find out degrees of freedom. It is very simple. Degrees of freedom are found by subtracting 1 from the sample size. Our sample size is 10, so 10 minus 1 will be equal to 9. This is our degrees of freedom. And in addition to degrees of freedom, we need to know the percentage. We have the percentage which is 1%, or we can say it is 0.01. Now we need to go to table and find out or locate the value of t. This is the table for students t distribution. The leftmost column represents the degrees of freedom, and the topmost row is the percentages for t values, or the area under the curve, you can say. So in our example, our degrees of freedom are 9, and the percentage of area under the curve is 1%. 1% means 0.01. Since it is 1%, since it is it should be on the left hand side of the 0, because the smallest values lie in that region. But on the topmost row there is no 1%, so we have to subtract it from 1. We can write it like 1.00 minus 0.01. It gives us 0.99, so which is here t 0.99. Now we have to look at the column of t.99 and 9 degrees in the row of 9 degrees of freedom. So we get it is 2.82. This okay, and our t distribution is actually symmetrical about 0, so it can be written like this: t 0 1 2 3, and on the left side -1 -2 and -3. So 2.82 lies very close to 3 on the right hand side of the 0, but at this point on the values which are smaller than this value of t are 99%. So we have to take a mirror image and go to the other side where only 1% values lie below that value, so that will be minus 2.82 here. So t for 0.01 or 1% is equal to minus 2.82. So the values below this minus 2.82 are only 1%, which lie within this region, this red highlighted region. This is how we can find out the value of t by making use of the t distribution table. But you can also calculate it using your scientific calculator as well. Now let's look at another example. In this example, a company manufactures car batteries with an average lifespan of 2 or more years. An engineer believes this value to be less. Using 10 samples, he measures the average lifespan to be 1.8 years with a standard deviation of 0.15. Means that there is a company claims that the lifetime of its average lifetime of its batteries are at least 2 years, means 2 years or more, but an engineer believes that the actual value is less. So he takes up the test and take 10 samples and measures that the lifespan is 1.8 years in those 10 samples with a standard deviation of 0.15. So in part A, we are asked to state null and alternative hypothesis. In part B, at 99% confidence interval, is there enough evidence to discard the null hypothesis? Okay, part A is very simple, state null and alternative hypothesis. So null hypothesis will be the claim from the manufacturer, which is mu, the average lifespan is at least 2 years or more, can be written as mu naught greater than or equal to 2, and HA alternative hypothesis can be a mu less than 2. So it is a one-tailed test, means the tail is only on the one side, the rejection region is on the left side of the critical value that we will find out. Now in part B, we have to write down some data first. Number of sample size is 10, and the sample average or x bar is equal to 1.8 years, and the standard deviation of the sample is 0.15. Okay, now our confidence interval or the confidence level is 99%. But first we will calculate our degrees of freedom. Degrees of freedom are calculated as n minus 1. So n is 10 minus 1 is equal to 9. So our degrees of freedom are 9, and our confidence level is 0.99, or we can also write it as alpha is equal to 0.01. It is because 100 minus 99 is 1, and that should be the rejection region. So alpha can be written as 0.01. This is the t distribution, and we have to locate the value, the critical value of t below which we can reject our null hypothesis. So since degrees of freedom are 9 and alpha is equal to 0.01, it is exactly same like in the previous example. So instead of going through the same procedure of locating the value of t in the table, I can simply write the same value here. T is equal to minus 2.82. This is the critical value now. So to the left of it is the region which is less than 99% or within 1%. So within 1% is the rejection region, and 99% is the acceptance region on the right side. So I will write it as the rejection region. This red highlighted one is the rejection region for 1% of the data, and 99% is the confidence level, means that is the acceptance region. Okay, this is the value of t that we have found out, the critical value, minus 2.82. Now we will calculate the value of t for our data from the data. So the formula for t and the t statistic is t is equal to x bar minus mu naught divided by standard deviation divided by square root of the sample size. Now we will put values. X bar is equal to 1.8 and mu naught is 2 divided by 1.15 divided by square root of 10. Now remember that it is 10. 10 is less than 30. So if it is above 30, we will use 30 or above, we will use z test, and below that we can use our t test as we are doing now. So 1.8 minus 2 is minus 0.2 divided by 0.40474. Okay, by dividing these values we get the calculated value of t to be minus 4.22. So minus 4.22 is smaller than our critical value, which was minus 2.82, means that it lies on the left hand side of 2.82, which is the rejection region. So we can simply now reject the null hypothesis based on this information, that the t-value of our test lies within the rejection region. It means that we can simply reject the null hypothesis, or we cannot accept the null hypothesis. So in conclusion, we can write it like this. Now we can write our conclusion like this, that our calculated t-value falls in the rejection region, therefore we cannot accept null hypothesis. Null hypothesis was that the average lifespan of the batteries is 2 years or more. Or in other words, we can write it like this, that at 99% confidence level, we cannot accept the claim of the manufacturer that the lifetime of the average lifespan of the batteries is 2 years or more. So we can simply reject that hypothesis, or we can reject that claim, or in other words, we cannot accept that claim or hypothesis. And that's all for now.